Hi, I'm Phil, and today I'm going to talk about an Arduino version of the garden project. So again, I'm using a mind map, very similar structure to the previous video. So I'll describe the system, its hardware, the communications protocol, walk through a bit of the software, and look at a couple of my projects and give you some of my references. So again, same objective as before, replace the Raspberry Pi 4 in the Microsoft FarmBeats project or kit, and use a Arduino computer instead of the more expensive Raspberry Pi. And the type of computer I'm using is an Arduino Uno. I'm going to use all the same Grove components that were in the FarmBeats for Students kit, but I will be adding an additional Grove module called the Grove real-time clock. And the price so far for the package that I put together, including the real-time clock, is 76 Australian dollars. And again, this can be used not only for STEM education, but to educate farmers for the next challenge. That is to make agriculture much more productive and economic, and also to consider shortages of resources and being able to manage the water much more effectively. And the next stage, besides collecting data and turning on pumps automatically, is to consider smart agriculture using AI, artificial intelligence, and machine learning. And also, because the farm is so extensive, we need good communications and connect directly to the sensors on the farm, and these might be remote. So in some ways, this is about systems integration. And while I've got a desktop version, the final aim is to look at this in the garden and eventually on the farm. So on the photo is the devices that came with the original Microsoft FarmBeats for Students kit. And this collects data and puts it into a Microsoft Excel spreadsheet using the Microsoft DataStreamer. And we've got very, very similar aims. We want to have the kit low cost. We want it to collect in real time. And eventually we'll be able to explore some of the AI models. I want to go a little bit further also and look at edge machine vision and AI with cameras, AI cameras from M5 Stack. So the original kit had a Raspberry Pi and a Grove hat so that all the other Grove components can be plugged in. So this is the equivalent, this is the replacement that I've got using the Arduino and the Grove Shield, where all the other components plug in. So in addition to these, I also add the Grove real-time clock. And the advantages are that you do it yourself. That is, it's not like the turnkey system that comes along with the original Raspberry Pi version, which is quite complex in its software construction. Here, you can start off with one Grove module and build it all the way up to get a working system. And the advantages of that are that if you have a problem with the connection or with the software, you can go in and discover and debug that yourself. So we'll be using the Arduino IDE, and we have the ability to add IoT using MQTT and connect to ThingSpeak or even the TTN LoRaWAN network. So one advantage is it's half the cost of the Raspberry Pi version. And I'll be using not only open source software, but all the modules are readily available and can work on the Arduino IDE. So for the hardware, I'm using a R3 version of Arduino Uno. I'm using the Grove Shield for Arduino, and it gives me up to 12 Grove ports. So here are some of the sensors. Exactly the same as the original FarmBeats kit, the Grove DHT11 for air temperature and humidity. And to measure the soil temperature, we use the probe and the DS18B20 waterproof temperature sensor. And for soil moisture, we use the Grove capacitive soil moisture sensor. And I'm also using the Grove sun sensor, which allows me to take measurements of visible, infrared, ultraviolet radiation. And the Grove dual button and relay are also part of the of my configuration. So this is how it's built up. So we start off with a Uno computer, and it normally connects via the USB to our Windows computer. And this is where we can do the programming on the Windows computer, but also collect data and run Microsoft Excel. Adding the soil measurements sensors. On top, we've got the soil temperature, and in the middle there, we've got the Grove capacitance moisture sensor. So you can see how it plugs in to the Grove Shield directly with the Grove cable and sockets. Then we add the ambient air sensors. So we've got the sunlight sensor on the right, and on the left we've got the, or on the bottom we've got the Grove DHT11 sensor for air temperature and humidity. And we just add the other sensor, the dual button. And the nice thing about that is that it only takes up one Grove socket, but we get two buttons out of that. And then the Grove relay. And finally, on the I2C port, I add the Grove real-time clock. So altogether, I'm using 7 Grove ports, 1 analog, 4 digital, and 2 I2C ports. To get all that data and communicate with FarmBeats Spreadsheet, we need a communications protocol. And I'm sticking to the original protocol. And you can see how I'm starting off with the Arduino time and date from the real-time clock. Then I take the soil measurements and the ambient air humidity, the sun readings, and finally the relay state and the button state, and also the logger state. And that's complies with the comma separated variable format that the Microsoft Excel and particularly the FarmBeat spreadsheet wants to get the data in. And for the software tools, I'm using the Arduino IDE, and it's all the program that I'm using and developing uses C++. So we use plenty of objects. So it's object-oriented language. And we use plenty of libraries to cut down the time that it'll take me to develop the program. And overall, the cost is just under $76. and I'm purchasing everything directly from Seed Studio. But that cost does not include the additional cost for delivery, which is probably about another at least $25 to $30. Okay, but despite that, it's cheaper than the FarmBeats project or the FarmBeats kit, which uses the Raspberry Pi. And here are the projects I'm working on. So I've incrementally developed this, and I'm about halfway through at the moment. So the project I'm going to show you is using the real-time clock. I've added the real-time clock, and it's Garden 6. And I want to add the data logger later on, and there's a couple of options that I could look at to do that. I haven't started that part yet. So Garden 6, I'll go through the objectives, the software, show you the results, and some of the issues and references. So my objectives, as before, I'm replacing the Raspberry Pi with a Arduino Uno computer. I'm going to use the same sensors and actuator, and that actuator is the Grove relay. I can use the agent in Microsoft Excel to turn it on and off. And for this version, I'm going to do all my data logging with Microsoft Excel. But it does use the time measurements from the Arduino kit that I've got. And I'm going to make this compatible with STEM projects in schools, and particularly the Corriwell School in the Blue Mountains for Year 7. They'll be able to start off with a simple sensor and build it up and make it accessible to the Microsoft spreadsheet. But eventually, I also want to make it more robust so that it can work in the garden, make it waterproof if possible. It's got to be easy to be maintained and repair. And I want to power it with a low-cost solar cell and LiPo battery. And later on, it can be extended for IoT and additional pumps if necessary. But it's also important to have the pump under emergency control, and I'll be using the red button on the Grove dual push buttons for that emergency switch off. So at the moment, it's still a desktop configuration, and this is what it looks like. So you can see I've got everything in Lego, including all the Grove components are in Lego wrappers, and these are all color-coded. So the environmental sensors like the DHT is in green, the actuator is in red, and the other sensors, such as the push button, are in Grove blue wrappers. And I've added additional annotation using Lego tiles that go on a Lego baseboard. Now here's the software, a little bit like Lego. It's all modular, and it's using plenty of open source and readily available libraries. So this is the start of my program, and where I'm defining the libraries and the global variables here. Then I move on to defining the objects. So I'm using the SI 114X module for the sunlight sensor, the DHT, the soil temperature probe, and finally the real-time clock. Then I introduce a function that allows me to get the real-time clock data onto Excel. So you can see this is where I'm establishing the objects, and that's my print function to get the real-time data to Excel. My setup program is just simply establishing the digital ports and the real-time clock objects. So you can see the buttons, the blue and the red button, and the relay button are all being set up here. And here I'm setting up the real-time clock. And to send everything off to Excel via the serial port, I use this simple sequence of print statements. And they're all in the same sequence that Microsoft FarmBeats wants to see them. And here are the results. So if you get a serial terminal, like this one using the Arduino IDE, this is what the results look like. And eventually, we want to get it onto the FarmBeats Excel spreadsheet. And you can see on the columns that I've got all the measurements going into the correct area on this spreadsheet. So the issues are, I've now got a calibrated sun sensor, and I've got the visible, infrared and ultraviolet measurements. And this is really good because it allows me to look at the contribution and do some experiments just using the light. And there's lots of other things I can do. I want to be able to add extra ports and add IoT. So the version that I've got is compliant with the FarmBeats protocol. And I've used the Grove real-time clock to give me those measurements, to give me the time measurements. I've still got plenty of other things to do. I want to port, look at the possibility of porting this to other computers and possibly using additional peripherals. The other computers I'm considering, two of them are the Seed Studio, their Zio computer with the expansion board. Now, the good thing about that is that it has Grove ports if you use the expansion board for it, and it can act as a router. So you can plug in from the Arduino Uno straight into the Grove serial port, and it can then send the data off to the Windows PC for further analysis. But you can use the both the OLED display, and also it has a micro SD card for local data logging. And another interesting possibility is to use the M5 stack tough computer, which is much more environmentally robust. So it's not, you can't submerge this in water, but it's splash proof and it has protection against dust, sand and dirt. And that's the sort of environment you expect. So this is a pretty good package. It has Grove connections and plenty of access to other pins. And my initial reaction, I've had plenty of experience with their other computers. They're all based on the ESP32. And with the additional expansion on those computers, I was able to get all the sensors to work. So I don't need any additional modules for the tough. It should be able to use the 3 Grove ports, and it has its own real-time clock, its own SD card for data logging, and it should be interesting to see if this one works. And this is how you would connect the various Grove sockets and additional pins. For example, the temperature, the probe for measuring the soil temperature, you would go directly into one of those pins. And if you need extra pumps, you could use this module from Seed Studio, and it would allow up to 4 pumps using the same type of relay that was in the original kit. Or alternatively, there's an interesting package from Electro, and they have a smart plant watering kit, which contains 4 soil moisture sensors and 4 solenoids to independently control 4 plants or 4 different levels. Now, this could be quite useful because if you wanted to do control studies, you need more than just one soil measurement and single point for measuring or collecting your results. It's got a real-time clock, and it also has a local OLI screen. And it's nice that it has Grove ports for data logging, and you could use the SparkFun data logger called Open Data for that data logging. And to go further, you could use any of the 300 Grove modules that are available from Seed Studio. And these include the Grove Wi-Fi, the pH sensor, the dust sensor, PM 2.5, gas sensors, for example, MQ2 for methane, oxygen, carbon dioxide, air quality. And there are libraries, Arduino libraries, that are available for all of these. And I've still had to do the AI vision, and I'll be using the M5 Stack AI camera to do that. And I also want to do it from multiple points in the garden. So that these are future challenges to extend the project. So thanks for listening. There will be another short video that follows this presentation, so stay tuned for that. Here are some of my references, particularly if you want to go on the Microsoft or the Seed website, or if you're interested in that M5 tough computer, the M5 Stack website is shown here. I've got lots of other mind maps that relate to this project, and here are some of them. And finally, I've used some images from other websites, and I want to acknowledge and give reference to them too. So thank you for listening.
Hi, I'm Phil, and today I want to talk to you about the Arduino Garden. It's a replacement of the Raspberry Pi with a Arduino Uno with a Grove Shield. It uses all the same sensors and actuators as the original FarmBeats kit, and just explaining what everything is. On top we have the Grove Shield, and it's connected to the push button, the same push button, L for log, S for stopping the pump, and we have a relay which can control a motor. And I have added, in addition to the standard Grove connections, a real-time clock for the computer, and it has a battery backup. And over here we have the Grove DHT11 and the same sunlight sensor that senses visible, infrared and ultraviolet. And over here we have the water moisture sensor and the same temperature probe, which is here. Now, just looking at how that all can be configured, if we just come down, and what we're doing is using Lego, and everything is annotated on the Lego board, so you can see the names of all the devices and their functions. And to get all this going, I'm using a Arduino computer. So something like this. This is the Arduino computer here, and it's the Arduino Uno. And on top of the Arduino Uno, we put on a Grove shield, which looks like this. There's the Grove shield, and those pins go into the sockets here. And after that, we just use Grove connections to all the sensors and actuators. Now, one limitation of my system here is that it doesn't have data logging. And in the future, I could compensate for that by adding an additional shield. So you can see there is room on top, not much room, but I could add a shield like this or an external computer. And some of the possibilities are to add a serial link, and I could use the Zoll with this expansion. It has Grove connections, but the important thing is that it's got a micro SD card on board, and it has a nice OLED display. Alternatively, I could use the M5 stack core computer, and it has Grove connections. It's got 3 of them, and if you compile, you should be able to compile for all the sensors that are on the other board. So if you want to go beyond one pump, you can add a Grove 4 relay module, and it uses the I2C rather than a digital port. So also from Seed Studio. Okay, so let's have a look and see how it functions. When I look at my FarmBeats spreadsheet, all the parameters, including the time from the real-time clock, the soil measurements, the ambient air, sunlight, and relay state are all over here. So you can see the measurements there. Now, if I press the button, I change the button state, and in the next round of measurements, that should come up. Here we've just changed the relay state, or the button state. And also, if we look at the moisture, at the moment it's high value of about 740, but if I dip the capacitive moisture sensor in the water, we'll see what it's like on the next round. So if we look at the round of measurements now, the soil moisture has gone down from 735 to 532. So we have all the measurements being logged. Okay, so thank you for listening.